Hello, FTC teams. It's Mr.Way here, head mentor for Team 7277, which is usually an FRC team, but we also run some FTC programs here. And this video is the effect of me being sent some parts that need to be reworked, and I think that some of the skills that we're gonna be sending back to my team might be useful to the greater FIRST community. So here's a bit of a CAD tutorial on how to make a 3D printed battery holder using a few specific parameters. In this case, we're going to talk about how to do a Tetrix battery holder attached to a Tetrix tube. Now I'm going to talk at a few places about how you can make this work if you're using a Rev system, a Studica system, whatever the case might be. I'm just going to give a little background here. I actually had my students from 14717, which is one of our FTC programs, send me these two battery holders for a 3D print. Our printers in the lab right now are under maintenance, and my one at home here could probably hog this thing off pretty quick if we wanted to. And I looked at this and realized that there are some places we can do some improvement. Now, first of all, kudos to the guys for actually pulling this one off. This is a very nice battery holder. It actually has a few features here. It actually has the Rev patterned on the bottom here to attach to a bar. It actually has the team number built right in, which I think is value added in a couple of different forms. And it actually looks like it's contoured to the battery. Now, it left me with a couple of questions, and I wanted to just walk everyone through how to design one of these with a couple more advanced features. And of course, this video is going to be sent back to my team for next week so they can re-engineer these and we can take another shot at them. That being said, let's jump into Fusion 360. Now, in Fusion 360, I've got a few things going here. First of all, I got an untitled document. I'm going to draw this up as if you're a relative beginner to Fusion 360. I want to walk you through the steps. I want to show you a few things, and hopefully you learn something from this. With Fusion 360, we start with an untitled document. I'm actually in a folder right now called Team 15259, which is another one of our FTC teams. I'm going to save this here because it's someplace I'll be able to find it. Battery holder. Give it a good descriptive name. All right, something you can work with. If I have more than one battery holder, I might be more descriptive on that one. Now, for this battery holder, I'm going to need a couple things. I'm going to need the Rev bar that it attaches to, or I'm going to need the actual Rev. I'm going to actually need the I'm going to need the Tetrix bar that it's going to be attached to, or I'm going to need the measurements of the Tetrix bar that it's going to be attached to. Now, I just want to throw out a shout out here to Team 542, who has one of the best Tetrix reference dimensions pages on the internet here. They do a great job, and I often use these to actually draw out the patterns. So I'm going to show you how to draw the pattern. I'm also going to show you how to just project the pattern. That's going to require a few different tools. The other thing I've got here is these actual bars here. I'm actually going to upload the battery for Rev right now, just so for Tetrix, so that I get the actual part that I'm going to need to base the design off of. So I'm going to go to upload. I'm just going to jump into my test prints, my desktop, and into my CAD library. So I got CAD files here, and you can see that I've got Rev, I've got FTC kit parts from Studica, and I've got Tetrix here. Now, the actual part you want for this is 39057, or whatever part number your battery has. Now, in order to actually find these step files, for those that are brand new to this type of CAD, you can actually jump onto most suppliers' websites. So here we have Tetrix, we have the battery we're about to work with, and we actually have a download button down here, and you can actually see that they've provided the step file for this one, which is excellent. Now, I obviously have it already downloaded, so I'm going to actually upload it into this folder. Another thing that's a really good idea in CAD is to have a master part file folder. Then you can bring parts over from it. Right now we're going to do this because it's a little more convenient, and we'll make it go from there. Now, when we're here, we've now got this battery holder, and I'm just going to close this down. This upload is going to continue, and we're going to get ourselves kind of stuck in here on what the actual interface is and some of the important tools. The very first of which is that we are actually going to bring this battery, there it is, into this drawing by clicking and dragging, and this is going to create a new component. Now, up here in this browser menu here in the top left, we actually have all of our components listed here, and we're going to be creating a couple of different things. We're going to be creating what's called a body, which is kind of like a component in progress to try to build the battery holder, but I actually want the battery here so that I can measure things from it, because that's very important. I'm just going to drop it in the middle, as long as it's oriented so the top side is up. That's all good. There's no problems there. Now, I'm going to make some design decisions here on this one. Unlike my team, who decided to make a battery holder that followed all of the contours of this, I'm actually going to make a battery holder that follows the contours on the inside, but is probably rectangular on the outside. And I'll show you why I'm going to do that in a bit, because they missed a part that I think is going to make this way more functional. Now, we're going to start every drawing with a sketch. And so to start this, I'm going to create the outside shell for this particular battery. And that shell is very simply going to give us something to start working with. So what I'm going to do is I am going to see what I have to work with here. I think the easiest thing to shell this based off of is going to be the top panel right here. So I'm going to start with a sketch. And I'm going to click this top panel. Now you notice we jump into 2 dimensions, and I can actually select the top face of whatever we had there. If I want to bring in faces that I didn't have as part of that selection initially, I can actually use this button up here called Project. Now your Project button is down here in the Create menu. Mine has simply been use the 3 dots here, and I've actually pinned it to my toolbar because I use this tool a lot. So here we go. Let's project out what we need. And in this case, I'm actually just going to project out the top of this. I don't need to do this because I started with it in my selection pane, but it's going to make this next step a little bit easier. All right. Now what I'm going to do is I'm going to use what's called an offset button. Now it should be up here in your toolbar. I'm just temporarily going to close this bar down so we can see more. And in the offset, we can actually turn around and we can select that line that we just created and we can offset it a certain distance. Now, one of the things that the team did that I didn't like as much is I think they just used the outside of the battery as their offset. And if that's the case, that's not so good because when you 3D print this, you're going to add somewhere in the neighborhood of a tenth to a fifth of a millimeter to the edge of all of your prints just because of how nozzles often work, depending on how your printer's calibrated. And that means that I want to make sure that I have a little bit of space. If this battery moves around by a little bit, I'm not that concerned. If it's too tight, we might have a problem. So I'm going to pop it out here, and just to see what I've got, I'm just going to zoom in on a part of it to see what my gap is between the battery and what's now going to be the holder. And I'm just really simply going to do a project on one of these lines here so that I can select it. And then I have a couple choices. I can use my inspect tool here, which is actually really good. And I can actually just inspect the distance between these two at 0.9 millimeters. I think a less than 1 millimeter gap on each side is probably something I can live with, especially with the tolerances of batteries. They, may not be exactly manufactured to what they're supposed to be. And so we're pretty much guaranteed that we've got something that will work here. Now, from here, I'm really simply going to decide what I want to be the outside of my battery here. Now I said I was going to do a rectangle on the outside of this one. Debating on that decision right now. Let's do this. Let's grab. Yeah, we are going to do that. We're going to use that same offset tool here to get started on that. In this case, I am going to. Oh no, we're not going to use the offset tool. We're going to use a line tool here, and we are going to drag out a new line here. Now, I have a couple choices of kinds of lines I can work with. I can work with actual lines that are going to affect the drawing, the model itself. I can also click over here to use my construction line. And construction lines are cool. Construction lines allow us to actually draw a line, and if you notice here, the line itself, which right now is vertical, it is going to be a dashed line. Dashed lines means it's not actually going to affect the actual part itself. It's just going to be used as a drawing line to reference things. I might actually want to throw a dimension on this and see what its dimension is. So right now I can see that this is, it says adding this dimension will over constrain the sketch. Click OK to create a driven dimension. Okay, and I'm going to click OK. It will over constrain the sketch, but I really was just using this to measure that this is 11.9, 11.9. There we go. Okay, now I'm going to decide how far out I want to go for the rest of my container here, the rest of my edge. I'm probably going to make my edge, I think 5 millimeters is probably about right. So I'm just going to go ahead and add another construction line 5 millimeters out. Now I'm going to do the exact same thing down here. I'm going to go to the edge, straighten it out. Then I'm going to go here 5 more millimeters. Okay. Now the purpose behind this really was just to create basically a marker point to put the edge of my rectangle. I'm actually looking at this now thinking I don't want it to be 5 millimeters. I probably want it to be closer to 3. You know what, let's see what this looks like, and then we'll jump back there. Okay, I'm going to do the exact same thing on the other side. I'm just creating a reference line as to where I want to put this, and where specifically I want to put my my overall shape here. There and there. Now, the shape I'm talking about here is actually going to be the outside of our shape here. I'm going to turn my construction line off. I'm going to click my 2-point rectangle, and I'm just going to float over these. And when you float over the edge of one of these, you get these little snap lines. Snap lines are important in CAD. They're going to allow us to do, and I'm just going to zoom in on the snap line process here. Float over this one, and you can see I can follow it along exactly perpendicular to the line itself. Actually, anything along the ortho plane here. and I'm going to click. Now, because of what I've done here, I now have the outside of a battery holder, and just looking at it, I don't mind it. If I take these numbers here, this 5, and let's say I suddenly want this to be 4, you can see that me moving the number on that line actually moved the rest of the rectangle. So we might turn around. I'm just going to click undo on that one. I actually like 5 millimeters. I think this is going to be a pretty chunky battery holder, but your battery should stay in place. Our team had a bad experience last week in a virtual competition where the battery bounced out of the robot. And we're going to talk about a feature of this that will actually make that not happen, which is very value added. I'm going to zoom up here. And I've got the top of my battery, and I actually kind of like the shape of this battery holder. One thing I might do at this point is throw what's called a fillet on it. And a fillet is just simply going to be allowing me to round off the corners, because I do kind of want to round off the corners. I think that has really nice style to it. There we go. And now that I've got that, we can press finish sketch. Now what you can see here that I have is I actually have an inner drawing, I have a middle drawing, and I have an outer drawing. Now that unto itself is not important. All I care about is that when I click on that outer drawing, it turns blue. If it does not turn blue and have a shape on it like this, it means I haven't closed one of my loops. I haven't connected 2 lines somewhere. If I haven't done that, this isn't going to work very well. Now what I'm going to do, I'm going to use the exact height of this battery to actually make this holder, because I don't want it bouncing up and down at all. A little bit of side to side is not going to harm anyone, but up and down is going to be a bit of a problem. I'm going to click extrude, which is your button up here now that we're in the 3D menu. And since I've already selected the shape, it's going to let me extrude. If I haven't selected the shape already, I can click extrude and click on the outside here. Okay, now I can click up and down. I actually have a menu over here, and the menu is going to let me do all sorts of things. I'm going to select one side because I really only need this to go in one direction, but if I was at the middle of an object, I could go both directions. Okay, I can choose my distance, but I actually want to choose to an object. What I'm going to do is I'm actually going to click on the bottom of the battery, and that's automatically going to, if we look on the front view with the view cube, it's actually just going to make this the exact height of the battery, which is awesome. That's exactly what I want right now. Okay, and I'm going to make this as a new body. What we're going to do is we are eventually going to turn this all into components, but for right now, a body is not a bad way to go. Now what you see we've got here, we actually have the startings of a battery holder. Actually, the startings of a really cool battery holder. Now, I'm going to build the bottom, and I'm going to build a cutout right here for the battery itself, and then we're going to build a bracket so that nothing can bounce out of this battery holder. And that's part of the reason we made the outside of this rectangular instead of making it wavy like the other design did. We're also going to cut our team numbers into this, which is going to be another tactic here. But let's start with the bottom. We made this whole thing 5 millimeters thick. We could go bigger or smaller depending on what you want to do, but what we're going to do now is we're going to put a bottom on it. And the bottom is super easy. We're simply going to click on create sketch. We're going to click on the bottom of the battery. Okay, now again, doing that and clicking on the bottom of the battery to create the sketch means we bring this object into our sketch pane. Notice that I can still select the battery because it's an object to itself, but this is really what I care about. Believe it or not, I don't have to add anything to this sketch right now at this moment. Until I want to cut the Tetrix holes into the bottom of it. And I can do that as in this step or as an extra step. Okay, if I choose to do it in this step, I'm going to have to go back a step. So I'm going to finish this and do it as an extra step. I'm going to do it as an extra extrusion so that I can actually cut the holes in the bottom of this plate. I'm going to click finish sketch. Now that means that now I can select the bottom of this and I can actually use an extrusion on it. I can also use an extrusion on the negative space in the middle, which is awesome because this is going to let me create a 5 millimeter edge on here. Now, if you want to know what you've done in your drawing, at the bottom here you have a timeline, so you can actually go step by step through it. And this shows me that my last step was an extrusion. If I want to edit it, I can actually right click down here and I can actually edit the feature. This means that when I go through the menu, I can see what I did because I missed something. Notice this bottom piece, this operation says join. Okay, I actually have the option of making this a brand new body, which I don't want to do. I actually want to join or merge this onto the previous body because they're all going to be the same 3D print. Okay, from here, I can press OK. Now what you see I've got is really the trappings of a really good started battery holder. Let's do a couple things here. I'm going to cut out the outside here, and the team did a great job of this one. If I jump back into Cura here, you can see that they've actually made a little divot on the side of this battery holder, which is excellent. We're going to do the same thing. Ours is going to be a little more aggressive because our battery holder is a little taller than theirs. We went right to the top of the battery, and we're going to go from there. What I'm going to do is the very first thing, I am going to click on this side of the object here so that I can get in here and figure out what shape I need. Now, a few options here. I'm going to recommend that I just create a construction line here, something to line me up along center. Actually, I don't even need to do that. I can just start my circle around center. Now, this one does not have to be particularly precise. I just need to make sure that I'm out of the way for the wire. Now, you notice that when I float along this top of this object, I get this little triangle right here. The triangle is important because that means it's the center of that line, which means I've centered my battery. I'm going to scroll down. I say an arbitrary amount here, and I'm just going to pop a circle on the side of here. I can say 16 millimeters because it's a nice round number. Okay, that's going to give me a circle that I can work with. From there, I'm actually going to cut it with 2 lines straight down, just so that I can get this cut out. We could also go fancy. We could go right to the corners. Why don't we do that? Okay, what we're going to do, we're going to float along the middle, and we're going to scroll along at a 90-degree angle along the side here, and then from there, I'm just going to connect this back up to the edges. Again, we're just utilizing what's called an ortho snap here, which is the snapping to vertical or a horizontal line in this case. Now, you'll notice that I have this top object, I have this bottom object. I'm actually going to use the trim function and cut off the top of this object. And then I'm going to scroll around, and I can just see in my drawing that this is going to cut out enough plastic to make there be enough space for this, which is awesome. That's exactly what I need. Now, if I try to extrude this right now by finishing my sketch and clicking extrude, I'm going to run into a little bit of a problem. Because what's going to happen if I extrude is I'm actually going to, you notice that it turned red? It's now doing what's called a cut function. And you'll notice that it's actually trying to cut out the cable of the battery model as well. Well, I don't want that. I want that cable to run through this gap. So before I extrude, I actually have to go back into my menu up here. I have to look at my battery, and I have to click the little eye next to it. The little eye is going to make the battery disappear. Now, did it disappear forever? No, it's just hidden. But as long as it's hidden, anything that I extrude, and I'm just going to pick an arbitrary amount to cut through here. In this case, it's negative 9 millimeters. Notice that my menu says cut now instead of join. And I have some choices. I'm actually going to go to object. I'm going to do this entirely properly. And I'm just going to jump it to the edge of this object so it cuts out exactly how much it has to. The reason I want to go to object is if I ended up changing any of the other parameters in this design, if I went back a few steps and I changed, let's say, the thickness of the shell, this will preserve the actual design. It'll actually keep it into a place that we can still work with it. Now, at this point, if I turn my battery back on, you can see it actually fits really nicely. Nothing wrong with that at all. All right, so 3 more steps actually. We're going to add the Tetrix holes on the bottom of this battery, and after we're done that, we're going to add the numbers to the front of this battery holder, and then we're going to add a little clip on top so that the battery can't bounce out. All real value-added things that we can do to this. So let's start. We're going to start with the Tetrix holes. I'm going to go back to my file menu. I'm going to grab a Tetrix bar, in this case 160 millimeter channel, and I'm going to bring it into my drawing here. Now, we're going to arrange it so that it's aligned about the same as this, and again, depending on how you want to mount your actual model together will determine how you want to do this. In this case, I'm pretty sure my team wants to actually mount the battery holder directly on top of a Tetrix bar. And that's kind of the implication I'm getting from this particular design here, so I think we're going to go ahead and work with that. Now, one of the problems that I identified in their critique of this was that this Tetrix bar, this is all good. There's nothing wrong with this design, but there's going to be a battery sitting on this. If there's a battery sitting on it and there's bolt heads protruding, they're going to embed themselves in the battery, and that could potentially be dangerous. So we actually have to make sure that we build a countersink into these. We're actually going to embed these so that we can put this on the bar without actually damaging the battery. So let's do that. We're going to align the Tetrix bar, and I'm going to play around with a new tool. It's called the Align tool. Right now, just taking a look at this, seeing how I want to do this. The Align tool is up here in the Modify tab, and you can see mine is actually tagged to the toolbar. Again, yours may or may not be. And I want to align basically the center of this Tetrix bar to the center of this battery holder. But right now I'm realizing that I don't have anything in the middle of there. Nothing I can actually move. I can align to. There's no snap points, which is a little bit problematic. So I'm actually going to add some planes to this. So I'm going to go up to construct here, and you'll notice that I'm going to capture position. I actually have the option here of creating a whole bunch of different kinds of planes. In this case, the one that I'm going to work with is called a mid-plane, and I just want to I'm creating planes so that I can connect these two objects. So I'm going to go mid-plane. I'm going to capture my positions. I'm going to click both sides of this battery holder. Now, what that's going to do when I press OK is it's going to put a plane right through the middle of the battery holder, dead center, which is what I need right now. I'm then going to go construct another mid-plane. I'm going to go from this side to this side. And that's going to create another plane, or at least it should. Ooh, I've created two of the same planes. I'm going to hit undo because I obviously was not paying enough attention to that one. In this case, I'm going to go from this side over here to this side, and that's going to create two planes that are going to cross each other. So now I have to go see, do I have an option to put a point through to pointed vertex? I might. No, I don't. Okay. I think I should actually be able to work with those two things, because this should allow me the ability to do the same thing. Actually, let me just float over. I might just be able to snap to the middle of a circle here. So we're going to use our align command. And align command is just simply letting you move an object onto or towards another object. So what I want to do is I want to take the center of this circle here, and I want to align it with the vertex where, or I guess the point where these planes meet. And selecting it might be a little tricky, but there we go. We got it. Okay. Now, in this case, you can see that it aligned all the centers where they're supposed to be. This is awesome. The reason I'm doing this now is because I want to make sure I get this Tetrix bar exactly where I want to, because that's where the holes are going to be. You can see that it actually didn't quite do the same thing I want it to, so if I click angle, I can actually turn which direction it's moving and make sure that this gets well centered. Now, you may not want this centered. You may want this battery holder off on one side of the bar. That's your prerogative, okay? This method that you use here, just make sure you snap to something slightly different. Press OK. Now, in order to cut those holes, I'm obviously going to have to make the battery go away. We're going to do the same trick we did before. I'm just going to make my notes go, or my file system go away here. I'm going to spin around my view cube, and I'm going to make my battery go away. Now, I obviously don't need these planes anymore. If you look over here, you're going to see that in my, it should be under my bodies here, actually should be under my, oh no, I may just have to manually click on these. If I right click on these, I can do a show hide thing, and I can actually just make them, they're still there, but they're just hidden for right now. Oh, they're under the construction tab here. I've got multiple planes that are in construction, and they are now hidden or not hidden, so I can see or not see what I want to. Okay, from here, we're going to cut some holes into this. How I'm going to do that is I'm going to click a new sketch, and I'm going to select the actual bottom of my battery holder. Again, we can capture position whenever we want because we're moving stuff around. Now, obviously, it's going to be really hard to draw those Tetrix patterns on the bottom of this because they're on the bottom of this. How do I align this? And the answer to that question is this project tool. Again, in your create menu, if you click on that project tool, you're actually going to be able to draw. Let me show you this. This is neat to oh, there's my sketch tool right there. This is neat to do. So I don't need all these holes. I probably only need a few of them. I think I'm going to use the four 3.7 millimeter holes on the side here, actually. Watch what happens when I click on these 4 circles here. Okay, I can click on the whole bar if I want the whole shebang. I want all of these, but really these are the ones that I kind of want. They're going to give me enough stability without popping holes everywhere. Now, you may decide, and I'm suspicious my team might decide, that they actually want more. They probably want these big ones as well, because we're going to talk a little bit about lightning holes as well to actually make this design a little bit less weighty, use less 3D printed plastic, that sort of thing. Okay, from here, I'm going to go back up to the top of my drawing, and you'll notice that in my projection, I've now brought all of those holes that I brought through into the top of my drawing. They're all up into the top part. And that's awesome, because what I want to do when I finish my sketch is I now want to extrude those downwards, and I might have to click on them individually here. But in extruding them downwards, that's going to allow me, just like we've done before, to actually cut them through the bottom of this 3D printed part. And again, I'm going to use, instead of the distance, I'm going to use the to object tool, and I'm going to cut down to the bottom. Now, at this point, you can see I have some holes here. I'm going to make that channel go away because I don't really need it, but you can see that I now have the pattern I want in the bottom here. Now, I specifically want to make sure that these holes have what's called a countersink in them so that I can actually bury the heads of my M3 bolts. I'm just very, very quickly here going to jump over to grab a reference for the 3mm bolts that I have here. Just let me hop over to a site here and confirm the size of those. You should always have, when doing CAD with any kind of bolts that are floating around, something similar to a reference for the size of the screws. I just use this one from engineersedge.com. I'm going to be using M3s on this one. I know it's a Tetrix tube, but it's still, oh no, you know what? It's a 3.7mm gap. Probably still going to use the sizing for M3s on these ones. Anyways, M3, you can see that the depth of the head here is H is going to be, there we go, about 3 millimeters. Okay, so we're going to aim for that. And we have the width of the head at A here is going to be about 5.5 millimeters. So let's go 3 and 5.5 for this drawing. We're going to add a new sketch because I need to do a new level. I need to do another depth or distance here. So in this case, we're going to do that. I'm going to actually click on the main panel or the main part of the drawing here because I actually am going to be able to, use the holes and actually snap to their centers, which is going to be very nice. Okay, I'm going to click here and I see that I actually have a 3.7 wide hole already. So I might actually have to jump over and grab my imperial bolt dimensions. We might have to actually attach this with imperial bolts. Again, I'm just going to jump into a new page here and grab the imperial bolt size. I'd have to do some conversions here. Standard bolt dimensions. Here we go. And hex bolts. I may not even have cap bolts here. You know what we're going to do? I don't have the specs here, but you're going to actually go out and find the exact height, exact width of your, in this case, number 10 heads, and you're going to go with that. I'm going to actually make them 8 millimeters just to be safe, but you're going to make them the exact size you need in this case. If I need to go edit this sketch, I can, again, just go into the timeline, edit the sizes. Life is good from there. Okay, I'm going to use a new tool on this one. I'm actually going to go down and I'm going to use what's called a circular pattern. Okay, that allows me to select an object and it allows me to select a center point. In this case, I'll use the middle one. It then lets me select how many objects I want to make, and it's going to copy them over in a circle, which is super neat. Okay, I'm going to use another command here called mirror, which is going to make life easy. I'm going to put a line down the middle here. Make it a construction line. You can make things construction lines before or after you draw them. And I'm actually going to go ahead and use the mirror command. It's in here in your, I believe, create menu. There we go. And I'm just going to select those 4 circles that I have there that I'm going to countersink. And I'm going to use a mirror line, which is here. And they're going to copy over to the other side of my drawing. Neat. Mirror command done. And from here, this actually makes life relatively easy because when I finish my sketch, I can simply go in and I can extrude those shapes that I just drew out. And I know that this is a 5 millimeter thick bottom to this. So I'm actually going to go -3, I think, on this one. And that's going to actually cut them into the bottom of the design so that they don't damage the battery. Those bolts will be nice and set in and they'll be nice and accessible and basically in a really good spot. Again, I like how light this bottom is going to be too. It's going to have, it's going to be really good for this robot. All right, 2 more things. I'm going to put our team numbers in this. And after we're done with the team numbers, we are going to turn around and put a quick hold down clip in the thing and then call this a 3D print. Team numbers are relatively easy. We create a new sketch on one side. We're going to take our text tool and we're going to use our text tool to draw our, in this case, our team number. I'm going to put 14717 on this one because it's the team that sent me the original drawings. And I'm going to select our team branding choice of font, which is Impact. And I'm going to make this thing relatively large, actually. I think this is 10 millimeter right now. I think I might actually go 30 millimeter. We'll make it big. Now, does it matter that I'm taking a lot of plastic out of this particular design, like that I'm using this in a big way? Not really. This 3D print's still going to be quite strong. Now, when I click finish here, you'll notice that I'm going to be able to actually extrude out these numbers, which is kind of what I was going for. It's going to let me actually cut them in here. And again, if I want to, I can do this completely properly. And I can use the to object button and actually cut these back to an object so that this is now hollow on the inside and shows my team numbers. Now, slight problem here. Everyone see that part of the number 4 there? That obviously will not print. That's a bit of a problem. Now, do I have some ways of getting around that? I probably could if I wanted to. Easiest way is probably just to throw a new drawing on the front here. Oops, sorry, new drawing on the front here. Project out part of that 4. And actually connect it to something. So we do this in one of our logos as well. I'm just going to simply do the thing they do in a lot of stencils and stuff, and I'm just going to add a couple bars there. Now, obviously, when you 3D print this section here, these numbers are going to require a fair bit of support material that you're going to have to clean up afterwards. Get familiar with your Dremel. It'll make your life relatively easy on this one. Okay, I'm just going to extrude this back. I'm going to spin it around and extrude it back to, again, using the to object button, to the back of the number 4. So it is, oh, what happened there? There we go. Oh, that back of that number 4 is curved. That's why. I'm going to keep this, I'm going to just keep this part way through, press OK, and that should hold that up just fine. It should make it so that I can still see the number 4 and that it still looks like a part of our logo. Excellent. We got one last thing we're going to do. We're going to actually put a hold down clip on this. All right. And again, I know that I've mixed some imperial and metric sizes here. I'm going to simply do this by attaching an M3 screw down into the actual design here. We're going to use an M3 by, I think, 16 millimeter screw. Might be a 20 millimeter bolt on this one. We'll see. Okay. How I'm going to do this, I know that my battery here potentially could bounce up and down in this bracket. So all I'm going to do is attach a little clip on this side that I can simply tie down and even possibly just turn sideways on top of this battery clip. And we're going to print it as a separate part and just attach it on. Now, some versions of 3D printing of this, you might just use a very small wood screw and provide a hole in the 3D printed material. That's not a bad way to do it. We're going to get, I think, a little bit fancier than that on this one. I think we're going to cut a we're going to cut a, if we're already doing some support material here, we're going to cut a little gap in this one. Okay, so first of all, let's create the top of this. We're going to go ahead and do a new sketch, and I'm just going to create a little clip. It's going to be super easy. I'm just going to draw a construction line from one side here to one side here, and I'm going to create a hole in the middle. That hole is going to be, I'm going to say 3.1 millimeters. We're going to put a metric 3 millimeter bolt through there. The 0.1 is just going to provide a little bit of play if I need to. I could do it 3 millimeters, be a really tight fit. You know what? That might not be a bad idea. Let's just go 3. All right. Oop. Type it in correctly, and then let's make it not a construction line anymore. Excellent. Okay, from here I'm going to create the rest of this bracket. I'm just going to use a rectangle for this. I'm not going to be particularly fancy. Let's make it a little more specific in that we make it, I don't know, shall we say 7.5 millimeters wide. And let's grab our 2-point rectangle again, and I'm just going to drag this out here. I'm going to make this 15 by using the tab key. Tab key again here. I'm going to make it, sure, let's go 20 millimeters. Why don't we? Okay, this is super easy, and again, we're just trying to create a tab of some sort to hold everything in place. If you want to get fancy, you can do whatever you want with this. We could fillet the corners and, again, make it a little bit round so there's no sharp edges. Avoiding sharp edges on a battery is actually a pretty good idea. All right. Press finish. Now I'm just going to go extrude out the parts of this I need, which are 2 pieces, and I'm just going to drag them up. I don't know. Let's keep the 7.5 thing going. There's no right or wrong answer here. Now I've got about 7.5 millimeters of bolt running through here. I may want to do that same maneuver we did before and just provide a countersink on this. There's nothing wrong with that. I'm just going to round up to 6 millimeters, and I'm actually going to cut this. I'm going to countersink this down, finish our sketch. Countersink this down by another 3 millimeters. Oop, clicked on too many things. Here we go. Let's try that again. -3. There we go. Okay, nice little countersink, so we can put a bolt in here. Now, what are we going to attach this to? Excellent. Oh, one last thing. You can fillet something in 3 dimensions, and I'm going to show you that right now. Up here in the Modify menu, we do have a few tools that we can play with. In this case, we're going to use the fillet because I'm looking at this going, I could see this needing a fillet to make it look even cooler, a little more space age. There's nothing wrong with that at all. Okay, you get creative with these ones, especially something like this that's really not a terribly structural element. It's just there to make things a little more functional. Last thing, if we've got this bolt, we're going to run the bolt down through this plastic. I think I'm going to make a little access port. I'm going to make it so that we can actually access it from the other side. First of all, let's make the access port first. I'm going to click here. I know that this is centered, so I can draw a quick construction line down, and I know I've got about 4.5 millimeters of bolt thickness here. I might do about the same thing. I might do about 5 millimeters of thickness here. I'm going to create a 2-point rectangle. Ooh, I'm going to make it not a construction line, and I'm going to make it a fairly arbitrary amount here, a fairly arbitrary space. I'm actually going to use what's called a move command. We haven't used this one yet, but a move command is really, really useful. It's in the Modify menu, and it's actually going to use a specific kind called point to point. Point to point is going to let me select the middle of this line and the end of this line, and it's actually going to, here we go. Before I do this, let me try this one more time. We're going to click the move button. We're going to click on the actual square, rectangle in this case, that we're working with, and then we're going to go point to point. Then we are going to click the center of this line as our origin point, and our target point is the end of this line, and you'll see it's going to align it, just kind of how we aligned the Tetrix bar before. I'm going to press OK, and since I've kind of accepted to myself that I'm going to have some support material for the 3D print in the team number, I could probably do this one with support material too. Click Finish Sketch. I'm going to click Extrude, and I'm actually going to extrude this. If I wanted to, I could actually extrude this the whole way through using the same trick we did from before, where we actually would extrude it to, let's say, the inside edge of this. Why don't we do that? Let's do this. Let's do this in a really proper way. Okay, now I've got an access port on this side. I could actually probably, if I wanted to, make that the whole height of this. To do that, I just go into Sketches, I identify the sketch that caused it, and maybe I decide, hey, this sketch, definitely not long enough. Let's make it a little bit deeper. Okay, Finish Sketch, there we go. That's a much lighter 3D printed part, especially if I'm going to do support material. Again, I'll knock that out when I'm done with the 3D print, and life will be good. Last thing I probably need to do is put a hole in the thing for the M3 screw, so I'm just going to create a brand new sketch. Oop, that went in the wrong plane. If you created a sketch you don't want, so sketch 11, here's one I didn't want, you can actually go back into your sketch menu and delete that. In this case, I'm going to create a sketch. I'm going to click on the bottom here, and I'm just going to scroll out to my view cube a little bit and use my project button to actually put excuse me, the correct size hole on there, and I'm going to cut that out and finish my sketch and use it as an extrusion. Now, at this point, we have something that is actually pretty good here. We have something that we can definitely work with. I'm going to use the same trick there. I'm going to go to an object and just cut it to there. Now, I realize now that we've actually created a bit of a slight problem. Right now, I actually have two bodies right now. I have this body and I have this body, and that's lucky. It's actually really lucky that I ended up with two and I didn't end up with one here. So I'm going to take my first body, which is this clip, and I'm going to have to print it as a separate part. So I'm going to right click on it, and I'm going to go Create Components from Bodies. Now notice that it came out here as Component 1. I'm going to rename it as Hold Down Clip. Name your file so you know what you're looking at, okay? And you'll notice that once it's a new component, I can actually move it around now, okay? It actually can become its own thing, which is fine. We're going to export it as a separate file for 3D printing. Now I've got another body here. I'm actually going to do the exact same thing to this, and I'm going to call this main battery body. And believe it or not, I now have something here that I can actually work with. If you're going to present this to somebody, it's possible you want to actually change the color on it. There's a few other tricks you can do in Fusion here. I'm just going to change these quickly to be white AB or white PLA plastic, which is what I'm going to print them out of by going down in the Appearances menu, clicking on Plastic, and I'm just going to use ABS for this one. It will, for all intents and purposes, do exactly what I need it to do. And there we go. Now we have two parts. This is a really good battery holder. This is something that we can work with. We may want to go to the other side, put our team number in the other side. We may just want to pop a bunch of holes in this thing to make it lighter. That's all good. Use less plastic. Nothing wrong with that. That being said, to throw this into the 3D printer, we have one last thing we want to do. We want to turn this into an STL file or another 3D printable file. In that case, we are going to go to our File menu here. We're going to go to 3D Print, okay? 3D Print menu is going to come up. It's going to say, what do you want to do? If you're comfortable with STLs, please use STLs. Unit type is millimeters because that's what we drew this in. Life is good. From here, we're going to uncheck the 3D Print utility. If you're using your own 3D printer, that's not really useful at sending it to other organizations. We have a few options for refinement and stuff like that. I usually use the default. They're not that problematic. Now what I'm going to do is I'm going to select the parts I want to 3D print. So I'm actually going to go select my main battery body, and I'm going to press OK. And it's going to pop up. In this case, I actually have a 3D printer folder here I'm going to use for this. There we go. And I actually go main battery body. Excellent. I might actually create a new folder here. Folder management is important. Okay, we're going to call this battery folder. And from there, we're going to jump into battery holder and throw the main battery body. We're going to do the same thing for the other piece. I'm just very quickly going to 3D print that. Selecting the other piece and moving it over, and it is battery clip. And there we go. Okay, from here I can jump back into Cura, and I actually can pull these, if I wanted to, 3D printed objects back into this space and just make sure they show up the way they're supposed to. And that really, at the end of the day, is, go back to my 3D printing folder, my battery holder folder, and my main battery body, and you can see that this is about the same size as that other one. Okay, spin it around, put it down here, and we can actually have something that might be just a little bit more functional because we've spent a little bit more time with this. I hope you enjoyed this movie. This is something that, again, I'm sending this to my teams so that they can actually continue to become better and better CAD modelers, as well as people who are building robots that just have more and more functionality, because you all want to become engineers out of this first robotics program, and that's a big piece of it. So I hope you learned something. I hope you take something from this, and if you have any questions, feel free to contact me in the comments below. Cheers.